I'm Crystal Portocarrero. I am the product manager for our advanced threat security product line, which encompasses a couple different parts. But really today, kind of what we're here to talk about is how to really leverage AI and automation within your network, right, to actually kind of gain better security, especially when we talk about cloud. And so, really when we talk about some of this, there's always a balancing act with security versus the business, right, and having business agility. And as things have changed, as this technology has kind of transformed over the years, especially with the move to the cloud, where that perimeter lives, what exactly security means is going to be different depending on exactly what you're looking at. But still, at the end of the day, right, you have to strike that right balance, and that balance is going to be different depending on what industry you're working at, in what country you're potentially working in, and then also what exactly your business does. So there's really kind of three different groups with different directives. And if you look at, say, the IT or network engineering, right, they're concerned with infrastructure, making sure that traffic goes from one point right to the other as fast as possible, right, just passing packets. You look at something like the security group, they're concerned with protecting not only the infrastructure, but also applications, users, data, and they have a different set of directives. And then we look at, right, developers and DevOps, and they're concerned with the application architecture, and they often see the network as dumb plumbing and security as a hurdle, right, to get over, get past, move around, because it slows down, right, the agility. And, again, it's just a kind of a nature of most businesses that these three groups are going to have different objectives that sometimes come into conflict with one another. And so overall, kind of, we look at the challenges for an enterprise and kind of bucket into three different categories. Right? We talk about cloud, the whole idea of the hard shell self-center, doesn't really work that well anymore anyway. You've seen the rise of things like zero trust over the last number of years. Because once you have a threat inside your network, right, that initial beachhead, or if it's an insider threat, it's easier to move around when there's already trust kind of built into the network. But also that whole perimeter only security perspective doesn't work as well as we move into the cloud, because that perimeter becomes really amorphous. And it gets even more gray when you look at, is this a cloud, like you're running your own infrastructure in AWS or Azure or Google Cloud, or is it a cloud, right, a SaaS-based service that you're actually trying to consume, and the security models for those are even a little bit different. And if you look at just advanced threats and the rate of change, especially since 2017, there's maybe I should have thrown that graphic in here, but you can look at how fast the threat landscape has really kind of exploded since about 2017 with like shadow brokers in the NSA, and then also malware as a service. You don't necessarily have to be a hacker to use malware. You can go out in the dark web, even some places on the regular internet, and just purchase malware, right? And some of them come as a service with a nice dashboard. You can see exactly how much, how many endpoints you might have infected, how many clients you have as part of your, say, botnet, to then launch a different type of attack. So, it's kind of commoditized there. And then again, we still have that whole stovepipe issue with different organizations within a business having different kind of objectives overall. And so then we move into, kind of where does AI fit into all this? And so kind of what is AI? Right, there's different definitions of AI, and it's really been a term that's been recycled over the years. It's been around for technically hundreds of years. If you think back to things like Ada Lovelace or Alan Turing, right? But now we're seeing it all the time in marketing, especially. And really, what it's about an experience, right? Taking user and operational experiences and kind of abstracting those, automating them, and automating the adaptation, right, to those experiences, and speeding up that, because humans just don't work that fast. And all of it, it's kind of the important part is that this is all kind of data-driven improvement. It's about getting smarter, more efficient, and more effective, not just more agile for the business. And then kind of what is AI not? AI is not magic. It's, I love this term, this quote here. If it's written in Python, it's probably machine learning. If it's written in PowerPoint, it's probably artificial intelligence, right? But the whole idea of AI is really almost like kind of a marketing term that's been abstracted a little bit, because it can mean a lot of different things. And I remember being at RSA this past March, March seems like a eon ago now. Every single vendor, every banner you see, it's like, here's our same product now, fortified with AI. It's like cereal that's fortified with vitamins A and Z, and whatever else. But what we're really talking about, right? That's kind of the marketing side, but what we're talking about here really is using machine learning. And so there's different types of machine learning. You have supervised machine learning, unsupervised, semi-supervised, and you can get to deep learning and neural networks. But the thing to keep in mind is that there are different types of models, and each is suited for different applications. So we look at something like supervised machine learning. What it's really good at, right, is we kind of give it labels, and then the machine learning model is generated and is able to take new data points and categorize them, right? And so it's really good for things like classification and regression. We look at unsupervised machine learning. Now we're just feeding, right, the machine, right, a lot of data. And what it's trying to do is trying to extrapolate those kind of labels from it. And we get an idea of like, hey, now we see it's labeling all of these, the top row here is cats and the bottom row here is dogs. And it's really, well suited to things like clustering and anomaly detection. And so there's different uses for, each type of these. So we're going to look a little bit more, I think, on the supervised machine learning side today for classification. And what we're really doing, right, is looking at behavior. Right, so behavior detection for malware. So the nice thing about behavior, when we talk about, detecting malware, right, you're used to things like, antivirus, which uses signatures, or IDS, right? Those all use signatures. It's a known, and it's a matching criteria. Those are really good for known, right, pieces of malware, and but for things that are unknown, things that we haven't necessarily seen, that we don't have a signature for, this is where behavior analysis becomes really important, because again, eventually attackers are going to take some type of bad action, and we can actually start to notice that by collecting those behaviors over the network, right, from the endpoint. So there's different places, within the network that we want to be able to start to collect that data. And then once we collect that data and kind of stream all these behaviors into, right, a kind of database, and we can start to actually classify that using machine learning and modeling. Because again, at the end of the day, what we're trying to do is gain kind of inferences and classification using machine learning to quicken the time to discovery. Because a human being, right, if you've ever worked as, say, like a SOC analyst, or actually digging into malware, we can do this by hand. It's just a long process. For a normal operations center, you might go through 3 levels of analysts, right, from the tier 1 all the way up to like a tier 3 analyst, before you get to the point where here's a file that somebody downloaded, and here's exactly what the malware is and what it does and how it behaves, and now we understand it. So a lot of it's just taking that time, right, and trying to quicken it, right, that time to discovery. Because the interesting thing is that malware, yes.
So on how do you decide whether it's a bad action or not? I know that a lot of malware just copy the same behavior as normal system administrators. Like a couple of years ago, NotPetya in the Ukraine, that was normal lateral movement with normal API calls. What makes the difference? What makes that behavior different from a normal administrator doing a push?
No, that's actually a really great question. And that's why behavior analysis is really important, because we're not looking at a single behavior and a single behavior. It's a set of behaviors, both direct and indirect behaviors, that we kind of correlate together and say, well, just because, again, a really good example is when you're installing a piece of software, is it actually looking to see what else is running on that PC at that time? That's a good indicator that it's malware, but there are some legitimate pieces of software that will do that. And so it's looking at multiple indicators. And so that's the interesting thing, right, about behavior data is not only, are we looking at indirect and direct indicators kind of as a total sum to try to create these vectors. But when comparing behavioral data to, say, again, going back to like the signature matching with antivirus signatures and IDS and IPS, you have about a 2-week time between when a new threat actually is discovered and seen in the wild for the first time to when, say, all the vendors have signatures to help protect against that. And during that 2-week period of time is where this type of behavior analysis is the most effective and the most important. And so we get into, right, the data science piece of this. And the first thing to look at is, how are you creating the model, right? Because we're talking about machine learning, really, it's just a model that we kind of create and then we're able to kind of categorize new data from. So I think this is a really good visualization of how some of this works. So if you look at the top left corner here with logical or logistic regression, you notice here that green line that goes through, this is kind of what the model would look like. And the distribution of, right, blue, which we could say is benign files, and red is malicious files. If you notice, if we use this model for this data set, it wouldn't be very good at predicting it because we'd end up with a lot of false positives or false negatives because it's not an equal distribution. When you look right below that, if we used logical regression, right, this kind of model for that data set, we'd get a much better model. But you notice that while most of the, right, kind of benign dots fall on the bottom and most of the red ones or the malicious ones are on top, there are some blue dots up top and there are some red dots right in the bottom. And that's because, you have to, with machine learning and doing all of this, there's some kind of fuzzy logic statistical analysis that's going on, and it's not perfect. So you will ultimately have some things that are going to be harder to classify than others. As you move into more like other types of algorithms you can use for machine learning, like we look here at the decision tree, and you can see the top right model is a lot more suited for decision tree, that distribution of data, where the bottom one, again, using decision tree for that doesn't make a whole lot of sense. So there's some data science that is really important to make sure you're choosing kind of the right type of modeling and algorithms to create this model. And then the other part is the kind of combining the data science piece with a lot of domain knowledge. Right, and the domain expertise is, but the first part is how do we even get that, all of that data set? And so when it comes to kind of how we look at machine learning for malware, right, specifically, what we did is take a bunch of samples, both benign and malicious, put this in a sandboxing environment, right? So everybody, I think, probably use some kind of sandboxing technology if you work in the security industry. It's been around for a long time now. And so what we're doing is just placing a file right in a virtualized environment and trying to see what it's doing. Sometimes we'll use bare metal analysis as well. You can look at traces that are happening at the user level, also traces that are happening at the kernel level. And so all of this information, right, of what actions and what's happening on the operating system when this file is kind of exploded, we take all that information out and look at different, again, indicators and different behaviors and start to map them together. And then from that, we'll get, right, those data points of distribution and then try to figure out what's the best way to build and train that model, right? Which algorithm do you want to use? We've used a number of different ones over the years and, again, done a lot of research on that side. But the important thing, right, is that you have a fairly large training set to create this model. Now, the training set, right, having a large number of samples is really important, but also the distribution of those samples becomes really important as well. Because if you're training based off a sample set that's not indicative of what it actually would be, looking at, so say for a normal enterprise network, if you were to train a model with, you say you have 100 samples and 80 of them are EXEs and then 10 of them are document files and 10 of them are PDFs, is that really representative of the types of file transfers you might see over your network? Probably not. And so the model is going to be skewed one way or another. So you also have to take into account the type and the distribution of file types and behaviors across what a typical enterprise network might see. We get all that information in, we turn that into, right, and create kind of a supervised machine learning model. And then we can use that to start to classify, again, files as either benign or malicious. And there's, again, different classifiers we use for different types of files, again, because there's different behaviors and different indicators mapped together that'll be different from, again, say like an EXE versus an ELF file on a, like say IoT device or a document file.
I have a question.
Yes.
So how long, I guess that's kind of two questions. One is, if I were to implement this in my environment, your learning thing, how long would it take for it to actually, learn and like understand and be able to start predicting things. And secondly, if I'm working on an environment that's highly sensitive, because I've worked in environments where cloud offerings are just not okay, they can't use them. They can't use things that like go to, send even data that is sanitized or anonymized or whatever. They can't do that, even if it is sending it that, in a safe way. They can't accept that risk. So is there something where, is it built in where it takes a set amount of time to do, and it can do it fully from your own infrastructure, or it can do it partly from what you have and partly from what you've set up on your side, if that makes sense?
So when it comes to how we actually train these models, we actually kind of do all of it under the hood, and there's not a whole lot of learning that necessarily is going to go on after you deploy the product. We do have a cloud-based offering as well as an on-prem offering. I used to work in the federal space a lot, and so with a lot of sensitive environments or environments that are air-gapped, you've got a lot of you look at like DoD, there's a ton of places that they just do not have internet access on that network because it's a confidential classified network, or maybe it's on a ship, right, and running in the middle of the ocean. There's no real internet access. So we do have an on-prem offering that works completely offline, and that's actually one of the huge use cases for this kind of technology. Is if you're offline, you're not getting signature updates on a regular basis. So the time in which those signatures start to fall off, normally, like I say, we see about a 2-week window. That window gets larger and larger the longer you are offline. So again, we have kind of an option for both. But as far as the machine learning model piece goes, we kind of create that. That's what our threat researchers do in conjunction with our data scientists, is kind of keep that model up to date. We do take samples that we get from our customers. So as a customer, you can choose to opt in and like send all of your, and it's an anonymized version of that file and some of the metadata to us. You can opt out of that. If you're running offline, clearly we can't get it, but you do have the option of flagging things as like false negatives, false positives. And even in an offline environment, you can actually just send them to us a different way, and they won't be automated kind of in the back end. But we actually take, oh, go ahead.
I didn't mean to interrupt you, sorry. I was just saying, so is it more of like a professional services kind of approach to building this intelligence, or is it like you already have this intelligence and we just take it and yeah.
So no, it's more of it's a product, right? So it's more, we have it, we've already built these models and we provide those to you as part of the product that you've purchased or software subscription that you've purchased. But we do, and going back to kind of the false positive, false negative, as a customer, you can send us that information and we do retrospective analysis. And so say we flag something as malicious when it actually was benign, what we'll do is take a look and say, well, what happened here? Maybe there's new behaviors going on in some new malware that we didn't recognize before that needs to be added to the model. So the model will then be updated and pushed out to all of our customers as an update.
Yeah, so Crystal, just to clarify, hopefully, and to build on what Zoe was asking there. So you do this for us and we can buy this as a product. What products, is it like a separate product that you then integrate with the rest of your Juniper environment? Is it embedded into all of the things that run Junos? If I want this, how do I give you money and you give me one?
There's a couple different ways. Because we have a cloud-based offering, and then we also have an on-prem option. But basically, you would purchase one of the two ATP products. So it would be the Juniper, ATP Cloud or Juniper ATP on-prem appliance. And then from there, you would just get kind of regular updates. And what we do is that's the kind of the ATP portion, right, is where the brains and all of the analysis is happening. But we actually make use of our firewalls. And so like the SRX acts as the collector in this case, and actually will parse out the files from the network traffic and send it to the brain. So whether that be the cloud or the on-prem kind of appliance option, it'll send it there. We also do offer collectors that are just kind of taps, right? So they're passive taps rather than just our firewall. So you have some options of, how do you want to deploy them? Where do you want to deploy them? For customers that are already Juniper customers using the SRX, the SRX makes the easiest way to kind of, you just turn on that functionality. It's already built into the software, and you just add either the subscription or the appliance. But if you are not a Juniper customer and say you're interested in using our technology, you can use the passive tabs to connect as well. And
Okay,
we'll actually go, I think, a little further into the topology and kind of how this might work in an environment in a little bit here too.
Right. Okay. I think that would be helpful, because at the moment, like this, there's a lot of technology here, and you're kind of explaining how you've created this AI stuff, which is neat and interesting, but I'm not quite sure. So, okay, you've done that, and if I believe you and it's cool, how do I plug that into my environment? How would I use that if I were to acquire it? How would that integrate into my existing environment, or how do I turn it on?
Yeah, so we'll look at that too just shortly, and also in the demo, you'll see how it all kind of comes together.
Okay, yeah, if we could get to that bit, I think that would be cool.
Awesome.
Yeah.
So I have a quick question actually about your learning methodology. It looks like you rely heavily on sandboxing for malware analysis. How do you guys handle, a fair amount of malware these days do sandbox evasion, do things that, basically short circuit sandboxing.
Yeah.
Do you have manual analysis that you've plugged into this? What other methods do you have around that?
Yeah, that's another great question. I'm actually going to get to that in just a couple slides. But the kind of high level is that, yes, we rely on sandboxing for certain pieces, but we do have we use customized sandboxes that actually, we try to mark down and get around some of those evasion techniques. So we have some sandboxing techniques that we use under the hood to try to get around a lot of the well-known ones, and we keep adding to that as time goes on. But we also do static analysis. We look at A/B signatures. So there's a multi-stage kind of piece to it. So it's not just purely sandboxing, because you're absolutely correct. It's not, you think of things like defense in depth. You want to kind of do things at multiple layers, because one is usually not the most effective. Any other questions? All right. So going back to the, kind of behavioral detection and why this, again, we kind of talked about the upsides of it, but not the downsides, right? Because it does take more time and it is more prone to mistakes. When you look at collecting behaviors, doing sandboxing, all of that takes a lot more time, right? Minutes rather than seconds. Then there's the analysis that has to happen on top of that. And it also is just more prone to false positives and false negatives. You look at something like static-based detections with signatures, it's a little bit more black and white. It either matches the signature or it doesn't. You have a false positive rate about 1 in a million with those types of technologies. And you look at a lot of machine learning technologies, again, because it's statistical analysis, and you take a look back at that graph with the linear regression, there's always certain points that don't really fall nicely. And while we can try to tune the model as best as we can, you're generally going to see a good false positive rate is about 0.1% or 1 in 1,000. That's a great rate to kind of aim for with this type of technology. Because if you think about it, machines just tend to draw odd conclusions sometimes. If you think about Google Translate, right? It's one of the most advanced natural language processing systems out there. But there's a lot of subtle nuances in language, that go back to, there's certain words that just don't translate from one language to another. There's also cultural context and things like that. So it's not perfect, right? It doesn't, the model doesn't take into account all of those small nuances. And the same thing with behaviors. If you think about, say, crime, right? I'm walking down the street, you're sitting there, maybe at a cafe, because you can do that now. But you see me kind of looking around a car suspiciously, and I'm looking through the window. Then you see me just punch through the window, because I'm that strong. I can punch through a car window in this example. Open the door, get in, and drive away. Now, there's 2 things that could have happened. I just stole a car, or 2, I locked my keys in my car, and now I'm driving away, and I have to go get my window fixed because I busted through it. So if you think about, how do you actually use these types of technologies on a network, it becomes a little more difficult in saying we want to be able to take actions and block malware, right? But just due to the nature of machine learning, you don't want to overreact. And it's the same, right? Going back to that example, if you were a cop now watching that happen, would your immediate reaction be to like tase me, throw me on the ground and arrest me, or to walk over like, hey, stop, and then ask some questions? Because you don't want to necessarily overreact based on some of the inferences that are made by these systems. And so getting into kind of what you were asking is, how do we try to overcome some of this? You can go to the next slide. Yeah. So we use multiple types of analysis. So the first stage, right, will be antivirus and some static analysis. So that's just pulling apart the code and looking to say like, hey, this function that's here in the code, this is used by, a known Bitcoin miner, right? And so we can do some static analysis of the code itself. And then there's the behavior analysis part. And we actually take all of that information, kind of feed it into that machine learning model to get a classification. But even with those, that multi-stage analysis, there's still classifications can be a little fuzzy. So to overcome some of the false positives and the false negatives, we'll actually try to look at some reputation data and compare it. So one thing we might do is say, okay, the model says this is a malicious piece of malware, but it also gives a kind of fidelity or confidence score. And so say the score is 6. Not super confident. It says, yes, this is malware, but I'm not super confident about, that prediction. And so what we can do is like, let's go out to virus total and take a look at the file hash. And if there's 20 other, vendor security analysts out there that say that this is definitely malware, well, machine learning model, even though it wasn't perfectly sure that it is, we can be really sure that's actually malware, right? Based on the reputation that we're comparing it to. On the flip side, if there's nobody else that found it, there is kind of 2 options for that. Either this is a true 0 day and we're the first ones to see it, which is kind of exciting, especially for those who work like threat research. That's an exciting time in a good but bad way. There's a 0 day attack on your network, but it also could be a false positive. And so that's where the retrospective analysis comes in, is to really look at it maybe a month later and say, hey, have we been predicting things correctly? And if not, why weren't we? And that's where our threat researchers really come in and start to look at, are there new behaviors being seen by like a new class of malware altogether? So all of that comes into play. And then the last thing we do is on top of the, classification piece, we'll also try to assign a malware family if it's an unknown piece of malware. So we can take, so you can better assign a risk to it, because that's more important, I think, as an operator, and what is this risk to your business? And so we do that by kind of looking at all the behaviors overall. And so say there was 20 behaviors that we observed that were malicious. 10 of them made it, were kind of indicative of ransomware. 5 of them were, a Bitcoin miner, and the other was some kind of Trojan. Well, again, it can't be absolutely sure, because this is maybe an actual true kind of new piece of malware 0 day. But based off of the behaviors, we're going to classify that as ransomware, which will have a very high severity, right, assigned to it, because ransomware can kind of rip through your network very quickly and do massive amounts of damage. Did I answer your question a little bit better?
Question on that one. How is the feedback loop from your customers for that? So if somebody confirms or say this was really a malware, or the opposite, this was, let's say, a false positive was detected, but was actually a legit flow, yeah? Yeah.
So actually, if you look at the slide right now, the report false positive, we kind of make that really, as you're looking at each individual detection, we have the option for all of our customers to report as a false positive or a false negative, and then you can add in comments, and our threat researchers will take a look at it and actually get back to you. So we've had very positive interactions with our customers who do report it. We assume that the ones who are not reporting anything are hopefully happy with the system. And from the ones we've talked to that haven't reported much, they've been fairly happy with the way in which we kind of do the scoring. And there's a couple pieces to that. Again, to try to avoid overreacting for a single event, we actually take into account multiple events and multiple detections to try to kind of create one high fidelity signal. So that was kind of the malware piece. We also will do detections of what we call Secintel. So this is detecting connections out to known malicious websites, URLs, CNC, right, botnets, things like that. So every time in this list, right, the intelligence feed that we have is like, correlation of a lot of our threat researchers. So it's the research they do, it's the some third-party feeds that we use, and also like things like the Cyber Threat Alliance and other alliances we're part of. We gather kind of all of that data, deduplicate it, try to make sure it's reputable, right? So look at where it's coming from. Is this a good thing to add based off of certain risk scoring again, and try to provide that to our customers. And then as an admin, you can kind of choose at what level you want to block, what level you want to just log, right, as interesting information. So this is kind of what the Secintel piece looks like from the UI, where you can see, again, for each individual hit, you'll get some information about why that IP might have been on the list, but also a threat level that's been assigned to it. And then you go one more slide. This is how kind of everything comes together, is we use this thing called the infected host feed, which is really just a list of compromised endpoints. And we decide, there's an algorithm behind what goes into that feed. So it's going to take into account malware, right, and suspicious downloads, all of the Secintel hits. So it's C2 communications, request to suspicious URLs and domains. And then also at the end here, we're going to talk about the encrypted traffic analysis feature that we're adding. And so it'll also include these ETA detections. And so each one of those each type of detection has a specific weight. And then each individual event also has a threat score assigned to it. And so those over time will move a host score, right, their overall threat level up. And
How
so,
do you-
go ahead.
Question, how do you recognize the malware suspicious downloads if they're over an HTTPS encrypted link?
So that's there's two ways in which we can deal with that. Part of that's going to be the encrypted traffic analysis, where we're actually just doing some SSL inference, just trying to look at certain details within the DLS handshake to determine, again, classify whether that connection is likely to be benign or malicious. And then for actually looking at files within like an HTTPS stream, we can proxy the connections. So just doing like SSL proxy, either forward or reverse proxy.
Will you cover your enforcement mechanism for actually blocking or stopping traffic, whether north-south or east-west in this context?
Yes. So we're going to show that. Actually, we're going to show some of that in the demo. So how this all kind of comes together, right, is each of those individual events will increase a host threat level over time. And then as an admin, you set, at what point do you want to start to quarantine or block those endpoints? And again, that allows you the flexibility to decide, how much risk is acceptable for your business and for certain like network segments where, say your main office, you might want to block at a level 6 and above because you have a bunch of salespeople who do, they're always on the road, who knows what they do online and what they're downloading. So a level 6 and above might be the right setting for that part of your network. But then in the manufacturing part, you have, machines that are actually, on the assembly line helping build cars. If they have a crypto miner on them, yes, that's something we probably needs to be dealt with, but is it a reason to shut down production? Absolutely not. And so you may never, right, there may never be a threat level in which you're going to actually cut off the and quarantine that device from the network. It's just something that's logged and alerted on as it needs to be dealt with. So it allows you to kind of set how much risk is acceptable for that part of the network.
So when you go and block these hosts, are you blocking the host entirely, or are you just blocking some of the traffic that happens to be infected or exposed in some way with like a TCP reset or something along those lines?
So there's a couple different ways that blocking happens. There is some inline blocking we can do. But if it's after the fact, like we had to go through the entire analysis pipeline to figure out that this was like a malicious file, it's kind of dealt with using this infected host feed. Because it creates a very bad user experience if your user has to wait even 2 minutes just to download, right, an email attachment.
Well, in that context, if we have a host that gets infected with some ransomware and it's starting to spread its joy on the rest of the network, can you walk through what the enforcement mechanism for that looks like, and how quickly it might stop the spread or how it's going to mitigate? I don't know, just how all those pieces tie together.
Absolutely. So actually, Josh, if you go to the next slide, this gives you a little bit of an idea of how we actually use our Secintel feeds. So there's multiple feeds, right? There's the kind of CNC malicious known malicious domains and IP feeds. Those go to our firewalls and the MX routers, so we can block it line right at the very edge. At the firewall level, right, we're actually blocking, again, this is all kind of north-south traffic, so this will stop an attack that started. Maybe they have an initial beachhead, they've installed, a Trojan, whether that came over the network or not, even. We can say they have a Trojan, they have a back door now to this, endpoint, but we can stop them from communicating out to the CNC server to download the next piece or the next actual payload to further that attack. And then we can also take, right, those indicators and the infected, right, a host list, which is right, just the quarantined or compromised devices, and we send those down to the switch port level on our own switches, also in our access points soon, and we can then block that specific host at the switch port level, so they can't infect anybody else, like in the case of ransomware. So kind of the idea there is that you can't always save patient zero because it's an unknown piece of malware. They got the infection and they'll have to be dealt with. But within a couple minutes, we can actually cut off their access to the rest of the network, even within that VLAN, right? Because you might be able to, again, do some of that through the firewall if you're routing to the firewall, but anything within that VLAN would potentially be under attack, right? And the ransomware could spread. But at this point, we could stop them by cutting the access from the network off to that device completely, while everybody else still has access.
Well, do you cover how this might address an APT or a lateral movement type attack where we don't have an external CNC that we have to address?
Yeah, so that's a really good question. So with lateral threat detection, that's where we have that's where our passive collectors come into play and are looking at things like, we have like an SSH honeypot built into that. And also we're looking at SMB traffic, right, which is how most malware spreads laterally. And so that'll start to look at that traffic. And again, because it's a passive tap, keep in mind that all of this is sent up as information that's analyzed and then would go into, well, now we see that that host is trying to create a file share. That's another indicator that will bump them up very high, and then we can block them using the infected host feed on the switches, routers, and firewall.
When you say quarantine, does it mean always we shut down the complete network connection, or you just stop SMB in this case when you detected something like that?
So by quarantine, we mean it's usually placed on like a quarantine VLAN. So maybe they just have access to the internet or to a set of remediation servers, or you can decide to cut off access altogether. So it could be a straight block, or again, what they have access to via, say, like a quarantine VLAN would be dependent on the configuration of the network.
So it is not like we know this malware is using these ports to spread out and then we just block them. It's always move the complete host to a limited network. Yeah. Okay.
Correct. Yeah, it's move the whole, because that host, regardless, we could be a little bit more surgical, right, with how we are, like the types of traffic we're blocking for them. But as a security analyst, you still have to go in, right? An incident response still has to go in and clean that machine up. So it's less likely to do damage to the rest of the network. And again, the risky behaviors it's already exhibiting. It's usually better to kind of pull them off the network altogether and remediate it and then allow them back on. The other thing with policy, so the way in which we're able to kind of send those feeds to all of our devices, it has to do partly with the automatable piece to Junos under all, right, the overall, or the underlying OS, but also our policy enforcer software, which kind of acts as almost like an API gateway to all of our different devices. The other interesting thing is the policy enforcer will actually be our connector into a number of our NAC integrations. So we can integrate with a number of different NAC companies, say Aruba ClearPass, Pulse Policy Secure, Cisco's ICE, and Forescout. So that's kind of the beauty of the policy enforcer. It allows us to enforce on our own devices as well as a number of third-party devices. So it kind of allows our customers to leverage their own infrastructure however they feel is necessary. Any other questions?
So on the slide, should passive taps and an appliance also be on it, or they can't leverage this?
Yeah, that's a good question. But the passive taps that we have don't really leverage it. They do have some intelligence built into them with some like Suricata signatures that are looking for C2 communications. But again, they're passive, so they're just kind of, that's a signal or an indicator. It's not something that we can actually enforce on. So these are kind of the enforcement points that we can handle with. Yeah.